Now that we've been introduced to rational expressions, let's look at multiplying and dividing them. Usually when we introduce a new concept, we start with addition and subtraction, but with rationals, multiplication and division is a little bit easier, so we'll jump to those first. When we're multiplying, we use this property, a over b times c over d is equal to ac over bd. Essentially what this says is if I'm multiplying, I can multiply the top divided by multiply the bottom. So let's look at a few examples. So here's my first example. And in order to make this a little less complicated, it's easier to start by factoring as our first step. So x plus 7 doesn't factor. The denominator here all has a 7 in common. I'm left with x plus 5. On the right, I need two numbers that multiply to be negative 40 and add to be negative 3. And that happens with negative 8 and positive 5 over x minus 8. I now look at what's in common. This has an x minus 8 on the top and the bottom, and an x plus 5 on the top and the bottom. And we are allowed to cancel over the two different fractions because of our property that we use to multiply fractions. This means my final answer would be x plus 7 over 7. This example is a little bit more complicated, but it starts the same way. We need to factor. The top, we have two numbers that multiply to be 2, which would be 2 and 1. And then we need to figure out the numbers for the second half. And I'll go ahead and tell you that it's going to be 2x minus 3 and x plus 5. This gives my outer term to be positive 10, my middle term to be negative 3, which adds to be 7. Over. And this bottom is actually going to factor into 2x minus 3, 2x minus 1. On the right, the only thing that multiplies 2 to be is 2 and 1. The only thing that multiplies to be 1 is 1 and 1, so we just have to figure out which one's positive and which one's negative. So it's going to look like this. Since we want a positive 2 on the outside and a negative 1 on the inside, gives me the positive 1. Finally, factoring here, I have x plus 5, x plus 1. We now want to start canceling things. Here's a 2x minus 3 on the top and bottom, a 2x minus 1 on the top and bottom, an x plus 5 on the top and bottom, and an x plus 1 on the top and bottom. And since everything canceled, that means my final answer here would just be 1. Now that we've done multiplication, let's look at division. To divide fractions or rationals, we use this property. A over b divided by c over d is equal to a over b times d over c. When we divide rationals, you take the second fraction and you flip it and multiply. Let's look at this example. The top of this does not factor, but the bottom does. And it would factor into x minus 4, x plus 2. For the second fraction, we flip it over and multiply. So x minus 5 over 1. We can now see that the x minus 4's cancel since they're the same on the top and the bottom. And then that gives us the final answer. On the top, x minus 5, and on the bottom, x plus 2. Let's look at this example. We want to start by factoring. On the top of the first fraction, we can see they have a 5 in common. And I'm left with 5x minus 6. On the bottom, they have a 7 in common, and I'm left with x minus 2. For the second fraction, we have to remember that we want to flip it. So if I look at the top of this, 25x squared minus 10x minus 24, that's a little bit trickier to factor, but you can brute force it and try out lots of options, or you can use some kind of computer program to help you figure that one out. Since we need to flip this fraction, the factorization is actually going to move to the bottom, and it factors to 5x plus 4, 5x minus 6. The bottom, we can see it has a 7 in common, and it's going to move to the top of the fraction since we're flipping it. I'm left with 5x plus 4. Now I can start canceling things. I have a 5x minus 6 on the top and bottom, a 5x plus 4 on the top and bottom, and I have a 7 on the top and bottom. That leaves me with a 5 on the top and x minus 2 on the bottom.